Welcome to the first online video lesson for PreCalculus. We're going to be continuing where we left off with half-angle theorems. So you want to title your notes as you would normally. I'm just going to move on because you can pause the video if you need to pause the video. These are our half-angle identities. Okay. Now, there are different ones for sine, cosine, and tangent. So the difference between sine and cosine is really subtle. It's right here, this plus or that minus, the difference between the two. So I remember that cosine, since it's still cosine, it's got positive. And since it's sine, you've got negative. So it's kind of like the opposite of cosine is sine, but that's not really true. So whatever. Now for tangent, however, we've got like three options. Now this one, that first one, that's the good one. Use this one. That one's good. Just use that one. All right, it's good. The next one is okay. I kind of think about like this one is if you're feeling a little frisky and you want to do something a little goofy, yeah, you can use that one. This one is bad. It's miserable. Don't use that one. The only reason you should use that last one is if you hate yourself and you want something miserable to work with. So that last one is bad. It is needed for a few proofs here and there. So that's why I give it to you, but it's not one that I want you to gravitate towards. Now, you might have noticed in each one, they've got, each one of them has sort of that plus or minus right there. That plus or minus, we do need to take into consideration when we're deciding our answer. We're not going to get two values out of this. We should only get one. So to decide which one we're going to use for that plus or the minus, you need to ask yourself, where is theta over 2? That's going to decide whether you use plus or minus. Well, let's look at this next example. So we got cosine of 60 degrees, and we want to use our half angles to do this. Now, we already know what the cosine of 60 degrees is. That was one of the things on the oral exam. All right, so we got the right answer there of 1/2. Now, what I want to do is I want to use the half angle identities, and I should find the same value. So if I get 1/2, I know everything worked out okay. So I've got a little cheat sheet over here. Hopefully you've got your cheat sheet off to the side. Of cosine half angle is plus or minus the square root of 1 plus the cosine of theta over 2. So I'm going to just write all that down. So that's my trig identity. Man, that's messy. So there's my trig identity. I want to figure out the something over 2. So I'm going to think off to the side here. I want something over 2 to equal 60 degrees because I want to replace that 60 degrees. So what divided by 2 is going to be 60? I think 120 divided by 2, that'll get us 60. So I want my theta in this case to be 120 degrees. So I'm going to do the cosine of 120 degrees over 2 because that's the same as 60 degrees. Now we've got that plus or minus. That plus or minus is going to be decided by that 60 degrees. 60 degrees is in quadrant 1. If we think about all students take calculus, I dare not do it because I do it backwards, but I don't know which direction is what because it's all mirrored. So in quadrant 1, cosine is positive. That's where 60 degrees is, quadrant 1. Cosine is positive. So I want the positive version of this thing. Everything else is going to stay the same. 1 plus over 2. We've got cosine. And then right here, I need to put my theta. I'm not going to put 60 degrees because I've got like that 6 degrees right here. That's what our theta over 2 is. I just want the theta, so just this 120. So that thing I kind of got from my thought bubble. Boop, 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 120 degrees. All right, so now we would figure out what the cosine of 120 degrees is. It actually is a little bit simpler for me to think about what is, if I convert it into a radian, what is the cosine of 2 pi over 3? I'm going to get it right this time. It's negative 1/2. 2 pi over 3 is in quadrant 2. and pi over 3 is 1/2. That's what we did earlier. So we get negative 1/2. So I'm going to put that into this problem. And now I've got a fraction and a fraction, so I want to try to clean that up a little bit. So I want to get rid of that divide by 2. So I'm going to multiply the top and the bottom inside of this radical by 2. Okay, well, that is 2 minus 1. That's 1 over 4. Whole thing gets square rooted. And I'm not squaring to solve. I'm just doing a square root, so I'm not going to get that plus or minus back. Square root of 1 is 1, and the square root of 4 is 2. And hey, that's what we wanted to get. That's where this thing started out with. It was supposed to be 1/2. We got 1/2. Ace. Everything was working out. Millhouse, I think. All right, next example. This one's going to be a little bit more interesting because this one we can't do on our own. I don't know 22.5. I only know I only know 30, 45, and 60 if I think about my golden nugget. The only ones I know are 30, 45, and 60. Those are the only things I know, and like variations of them. So I want this 1/2 to be one of these things. So I'm once again going to think about 22.5. We want something divided by 2 to equal 22.5. Or you could reverse it and just do 22.5 times 2, and that'll tell you what thing we want to put up top. It's 45 degrees. 45 degrees divided by 2 gets us 22.5 degrees. We're doing half angles today, so it makes sense to divide by 2. So we're going to make this, instead of the sine of 22.5, we're going to make this the sine of 45 degrees over 2. And again, that 45 degrees is going to take the place of our theta when we come to using our sine half angle, because now we've got it set up to use sine half angle. I'm going to copy down that identity real fast. Notice that I got that negative. Since we're doing sine half angle, it's got that minus instead of a plus. That's the only difference between sine half angle and cosine half angle. And I put that 45 in where theta is because 45, here, let's pull this up too. 45 is in this theta spot, and then we also want to have that same theta spot. We want to have that 45. To decide the plus or minus, we're going to take a look at where 22.5 is. 22.5 is in quadrant 1. It's less than 90 degrees. And in quadrant 1, sine is positive. Since sine is positive in quadrant 1, we're going to use the positive case. It's a little goofy because 45 is also in quadrant 1, so it seems like we're just doing it off of 45, but we're not doing it off of the 22.5. All right. Now, cosine of 45 degrees, I'm going to figure that out next. Now, once again, we've got a fraction inside of that fraction. I hate that. So I'm going to multiply top and bottom by 2. Now, we do want to square root the top and the bottom like we did before. We're not going to get a plus or minus again because we're not square rooting to solve. We're just square rooting to try to simplify this. In the denominator, the square root of 4, oh, that's easy, that's 2. But in the numerator, something weird is going to happen. We get this. Yeah, that. And that you might look at and say, ooh, that's gross. I don't want to leave it like that. Ugh, yuck. The square root inside a square root, shouldn't we simplify that? The answer is technically we can, but we don't want to. It is super gross to do, and it's just not worth our time. Even if we weren't doing this distance learning stuff, it is not worth our time. So we're just going to leave our answer like that. Having a radical inside of the radical is okay, but if we have a radical in the denominator, which we're about to see, we do want to deal with that. I've got one more example I want to show you where we get that radical in the denominator. Now we want to simplify both of those. We got fractions and fractions. Let's get rid of that. So multiply top and bottom by 2. So we get 2 plus the square root of 2 over the square root of 2, which is negative. Now we got a square root in the denominator. I hate that. I don't like square roots in my denominator, so we're going to multiply again. We're going to multiply now by that thing we want to get rid of, the square root of 2. So the square root of 2 times 2 is 2 square roots of 2. And the square root of 2 times the square root of 2, hey, that's just 2. In the denominator, we've got the square root of 2 times the square root of 2. That is 2, but it has a negative on it. I'll extend my screen a little bit here. Now, hey, we can divide that thing. We can look at all those 2's. We can do the heart rule of division. We can divide these 2 and divide these 2. It's the division property using division. So we get negative square root of 2 minus 1. And that is our final answer. So those are our half-angle identities. A quick reminder, when you're deciding whether to use positive or negative in front of these things, you're looking at where the half version is. Not where theta is, where is theta over 2? So where is, in this case, it would have been 5 pi over 8. In the previous one, where is 22.5? Not where the actual theta is. That happens inside of these things. Also, too, with these ones, always use this one. This is the best one to use. Just use this one all the time. Do this one if you're weird, and use this one if you hate yourself. The reason you get these other ones is they are used in a couple of proofs here and there. That's all for our video lesson. What you need to do now is there's a practice that I would like you to do. See how well you can do a couple of these things. The main goal of this practice is to see how well you've understood what's in the video, and then I can clarify any questions that have come from this video or questions that I see from the practice. Thanks for watching. I'll see you in a bit.